I'm David Van Branken, Associate Dean of Undergraduate Education in the School of Physical Sciences. And on behalf of Dean Bullock and the entire school, I'm proud to announce Professors Jonathan Feng and Kim Edwards as this year's honorees for the School of Physical Sciences. Professor Jonathan Feng is being honored for his innovations in two courses, a majors course in thermal physics and a non-majors course for the Honors Collegium. Physics 60 is one of the first courses involving a deep dive into physics and plays a critical role in the retention of majors. Professor Feng was able to draw students into the challenging material. One of his students said, "This class was my everything this quarter." Professor Feng was clearly passionate about thermal physics, and it showed. The lectures were interesting and engaging, and all of his lectures were very stimulating, especially as the material became harder. Professor Feng has also completely redesigned Physics H90 as making sense of our senses, the physics of sound and light. He made full use of pedagogical tools such as demonstrations for sound and light, web simulations, auditorial and optical illusions, quiz bowls, and thought experiments. He even invited students to play instruments before the start of class. Professor Feng made complex topics interesting and accessible to students, including topics like quantum mechanics and relativity. One of his students said, "Professor Feng's course was very clear and structured with amazing use of demonstrations. It was very obvious that Professor Feng was there to help students and wanted us to succeed. He encouraged collaboration and discussion. Overall, this class was one of the most well-taught classes I have experienced at UCI." The school is honoring Professor Edwards for successfully transitioning UCI students through the general chemistry laboratory curriculum during the COVID pandemic. Professor Edwards leads the massive general chemistry laboratory program for non-majors, majors, and honors collegium students, serving about 1,600 students each year. At the outset of the pandemic, with little time, through Herculean effort, Professor Edwards was able to create an online curriculum that successfully brought UCI students through a remote version of general chemistry laboratory courses. Professor Edwards recruited and managed a team of talented students to create new remote content, film experiments, develop multiple versions of data sets, and guide students through the experiments. Professor Edwards used the student feedback to refine the remote lab experience throughout the pandemic. As UCI returned to in-person classes, Professor Edwards focused on the development of new laboratory courses and activities to teach the skills that were needed to safely transition students back into the chemistry laboratory courses. Remote technologies are not yet able to replace the in-person laboratory experience, but the efforts of Professor Edwards allowed large numbers of UCI students to get the coursework needed to stay on track toward graduation. Now let's hear a word from our honorees.
So some of the favorite teaching moments I've had in the last few years have actually been while doing demonstrations at home. So I'm in the Department of Physics and Astronomy. We have a fantastic library of demonstrations and a fantastic staff to bring them to the lecture hall. And of course, during COVID, we couldn't do any of that, which was terrible. But in the category of sort of making lemonade out of lemons, we realized that actually it opens up some new opportunities too, being at home. As an example, in one of my courses where I teach about the physics of heat, I got two balloons, one filled with air and one filled with water, and went down to my kitchen stove, a gas stove. And first thing we did is we held the air-filled balloon over the gas flames, and as you might expect, instantly popped, spewing pieces of balloon all over the kitchen. And then I asked the students, well, what happened if we take the water balloon and hold it over the flame? And as I put it closer and closer, I heard students on the Zoom call saying, "Don't do it, watch out," which was great because when you put a water balloon over the flame, it doesn't burst. And so that was a fun demo to do. And we got to, of course, discuss it and understand it. Another fun demo is in the physics of sound and light. Of course, I teach to a number of non-physics majors. We did a demo where we took a standard old coffee cup like this one with a handle and clanked a spoon on it. As you go around, you hear that the tone goes up and down. which is a lot of fun. And the cool thing was most of the students had coffee mugs just sitting around at their home, wherever they were. And so they could also do this demo too, in a way they couldn't do if we were doing it in a normal time in a lecture hall. And of course, we got to understand why it does that. Goes up and down as you go every 45 degrees, it changes the sound. And so these have been really fun. One of the best things that happened is after a recent course, one student wrote to me and said, you know, I now see the world in a different way, whether it's from the clanking of my spoon on my coffee mug, to the rainbow on the wall, to the headphones I put on. And of course, that was extremely rewarding because I think all of us lecturers hope that students will leave our course seeing the world in a new way. So I'd like to thank everyone for this award, and also the students I've had in the last 20 years for the chance to teach them.
My favorite teaching memories are in the Anteater Learning Pavilion. Before ALP opened, I had tried different active learning strategies, but always felt the traditional lecture hall was a significant barrier. Most of my lectures were Socratic, which was typically a conversation with a few extroverted students, and then I sprinkled in a few active learning exercises. The first day I taught in ALP, I realized to teach that way would be a complete misuse of the space. So I set about finding ways to use the unique tools available and putting myself among the students, not in front of them. Examples of student group activities that I use are having the students use the monitors at each pod to watch a video, then practice writing laboratory observations as a team, or creating sketches together of microwave rays from a photon tunneling video that connects to the week's experiment. I have student groups use whiteboards to predict Raman spectra of functionalized nanoparticles, and sketch water molecules and their hydrogen bonding to represent a water droplet on a hydrophobic surface. I asked students to use the small handheld whiteboards to create phase diagrams with string, magnetic clips, and labels. And then I have them use more string to show the effect of solute addition on their phase diagram. The ability to facilitate such group activities is far more enjoyable than any lecturing I did before. Instead of putting together narrative lectures, I build exercises that ask students to interact with each other by speaking, drawing, writing, or manipulating demonstration materials. The students' thinking is revealed to themselves, their peers, and to me. I absolutely love the improvisation that occurs in a student-centered classroom. I like when the room is buzzing and I need to bring everyone together with a loud voice for an occasional recap. This was especially true this past quarter. After not teaching in person for 2 years, I found stepping back in an ALP classroom incredibly energizing. For one class session, I had students don party hats and carry balloons to demonstrate the different chemical interactions involved in thin layer chromatography. The initial student reticence to putting on the various colored party hats and lining up in the aisle slowly changed to amused attention. Students responded to my questions about what needed to happen for them as a group to demonstrate how the various chemicals interacted, and they willingly participated in the demonstration. The students were having fun, and so was I. Most left their party hats on for the rest of the class and were actually disappointed when I asked for them back.